Hello students. Today we are going to continue further uh, about what uniform circular motion. Okay, so let me write down first that what does it mean of what the uniform circular motion. So when when a particle when a particle moves on a circular path with a constant speed constant speed constant speed or with a constant angular velocity constant angular velocity then the motion of the particle particle will be called as called as uniform uniform circular motion. Okay guys, okay, so this is the definition of what the uniform circular motion. Let me physically interpret this thing to you guys so that you can understand that what I am trying to convey here. Okay, so if you see guys, suppose if you have a circular path like this, okay, if you have a circular path like this, and this is the particle that we are looking at. Let's say guys, this particle if this particle is moving with the speed v here, and at a certain moment the particle is here, and still what the speed is what the same. If you see, direction is keep changing, but the magnitude is what guys, magnitude is same. Okay, the magnitude is what guys, same. So it means what, this kind of a motion will be known as what guys, a uniform circular motion. Here there are few things that you can see, that in in equal time in equal time it is covering equal distance equal distance. If you see guys, here let's say in 2 seconds if it has covered this much length, so in the next 2 seconds also it will cover what, the same distance that it has covered here. Okay, so this distance is equal to this distance is equal to this distance if the time taken in this interval and this interval and this interval is what, same. So this is what, this is the meaning of what, that having a constant speed. I hope you are getting my point. But along with that I have also said that it is having what, constant angular velocity. So guys, if you see here, the direction of angular velocity will be what, in the outward direction. If you see, the direction will be what guys, in the anti-clockwise. If you see, the motion is what, anti-clockwise. So if you curl your fingers in the anti-clockwise way, right hand fingers, if you curl in the anti-clockwise way, you will see that your angular velocity direction will come guys, what, in the upward direction. Okay, it will come in the what guys, in the upward direction. Okay, it will come in the upward direction. And because the angular velocity must be constant, okay, it means what guys, like if let's say in 2 seconds it has covered delta theta here, so in the next 2 seconds also it will cover what, delta theta here, and the next 2 seconds again what, delta theta here. So that is the idea of what guys, that if a particle is doing uniform circular motion, this would be the thing. Okay, now guys, the first thing that I want to discuss about here is what, relationship 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 between 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 velocity and angular velocity. Okay, this I want to discuss it here, guys. Okay, that what is the relationship for velocity and angular velocity. Try to remember, guys, these relations that I'm going to develop is a very general relationship. It is developed for an instant, so it is not only true for what uniform circular motion, it is going to true for what the non-uniform circular motion or accelerated circular motion of all the cases. Okay, of all the cases. So remember, guys, the derivations that I'm going to do now are very very important, and they are going to be work everywhere in the uniform circular motion. Okay, whenever we are studying a motion of a particle on a circular path. So guys, see, the thing is, the one relation I had shown you in the previous class, that is ds. Okay, ds is equal to what? Is equal to d theta cross r vector. Okay, d theta cross r vector. This is for a very small displacement. I have told you that this relation exists. Okay, and guys, you have to take it is as it is. Okay, like there is no formal derivation that from where it has came is not there. It is defined like this way, that you have to accept it. Okay, like this is the way that we have defined this thing. Okay, because I can explain this thing, but just I will explain just to make you to understand, but I'll tell you that there is no like a formal derivation that it is came from somewhere else. No, it is defined like this way. So please take it as it is. Okay, please take it as it is. Okay, so now guys, if I want to develop the relationship between what the velocity and the angular velocity, so what we have to do, guys, we know that velocity will come by what? ds by dt, and angular velocity will come by what, guys? d theta by dt. Okay, so it means we have to differentiate this relationship in terms of what, guys? Time. So let me differentiate that, please. So ds by dt is equal to what, guys? Here there are two variables, guys. Okay, there are two variables, d theta also and r vector also, and because the particle is doing the motion, so r will be what? R vector will be also what? Keep changing, you know that. Okay, so guys, if we differentiate this, what we will do, it will be like this: d theta by dt cross r. Okay, guys, don't change the order. As the order is there, you follow that order only and do the what? Differentiation using the what? Product function rule. Okay, so d theta by dt cross r plus d theta cross dr by dt. Okay, dr by dt. So guys, here if you see, d theta by dt is what? Nothing but omega cross r plus, guys, here if you see, d theta cross dr by dt, guys, can be written as what? Can be written as d of mod r cap divided by dt. Okay, and guys, if you see that r is what? Constant for a uniform circular motion. Okay, for a uniform circular motion, r is constant, so we can take r outside, guys. Okay, so let me take r outside, and now in this, d theta cross dr cap by dt. Okay, now guys, if you see, this is what? Omega cross r plus mod r d theta cross, here guys, it will be what? You know that omega theta cap. Okay, omega theta cap, this will be the value of this. So if we, guys, see here, r and omega you can take outside, r and omega you can take outside, and what will be remaining, guys? d theta cross theta cap. Of course, guys, this direction and this direction will be what? In the same direction. So we can say that cross of what? Two vectors which are in the same direction, means having zero angle, will be what, guys? Will be 0. Will be 0. So guys, this will be what? 0. So what we got, guys, here the relationship is v is equal to omega cross r. V is equal to what, guys? Omega cross r. This is the general relationship, guys, between what? Between v and omega. Okay, very important relationship, guys. You have to keep this thing in your mind, that how we have developed the v in the vector form, omega and r. Okay, guys, For general calculation purpose, you can just directly write B is equal to what, R omega. This is what, just for calculation of magnitude you can use this, but this is what guys, this is the most general form, you can say this is the most general form which will be helpful in the analyzing of what, a circular motion. It will give you the direction also, it will give you the magnitude also, and guys this will only give you the magnitude when you are analyzing the circular motion, not the direction and all. Okay, and the more rigorous application of this you will see in the future when I will discuss this. Okay, when I will discuss in the future, you will see that it has a more rigorous application. Okay, okay guys, so one relationship that I wanted to develop here, I have developed, that is what, between the velocity and the angular velocity. Now guys, let me move towards a very important things. Okay, now guys, see, what about acceleration? Okay, what about accelerations? Acceleration in uniform circular motion, uniform circular motion. Okay, uniform circular motion. So something very important guys, here we are going to discuss today, please pay attention. Okay, so if you see guys, if somebody asks you that what is the value of this, is this 0 or not 0? Okay, dv by dt is 0 or not 0? The answer would be what guys, the answer would be that it is not 0. You will say, sir, speed is not changing, then why it is not 0? Okay, that could be a very genuine doubt that student might have. So guys, try to understand, we are talking about the rate of change of what, velocity vector, not the magnitude of velocity. Okay, we are talking about what, rate of change of velocity vector, not the rate of change of what, magnitude of velocity. So guys, if you see here, the velocity is what guys, keep changing. Velocity is what guys, keep changing. If velocity is keep changing, it means of course guys, the magnitude is not changing, but the direction is what, changing. Because the direction is changing guys, we can't say that 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 dv by dt is 0. No, this is wrong. Okay, the answer would be what guys, that dv by dt is equal to not 0, is equal to not 0. Okay, so this you have to keep in mind, that even in the uniform circular motion, the rate of change of velocity is not equal to 0. But if somebody asks you like this way, that what is the value of this? Okay, then answer is what, 0. Means d of mod v divided by dt equal to 0. Mod v guys basically represents what, the magnitude of what, magnitude of what, speed. Means the rate of change of speed, the rate of change of speed is equal to what guys, 0. The rate of change of speed is equal to 0. So guys, what is this? This acceleration guys, this acceleration have a specific name in the circular motion, which is known as what guys, a tangential or tangential acceleration. Okay, tangential acceleration. What does it mean guys? Let me discuss it properly, and then we will go about the other form of acceleration guys. Okay, so see here, d mod v by dt equal to 0, which is what guys, at, which is equal to what, tangential acceleration. What does it mean of tangential acceleration guys? Try to understand this. Okay, so guys, if you see here, the thing is that here the speed was what, v, here also speed is what, v, and here also guys what, speed of v. Okay, so guys, try to understand, if there is no force is acting here, then the speed will not change. If there is no force is acting here guys, the speed will not change, either in the same direction or in the opposite direction. If it is not along the direction of velocity, then it is not going to change its magnitude, it is not going to change its magnitude. It means what guys, it is, if you see, this force is always acting what, tangential to what, tangential to the curve, and or you can say along the velocity direction. So if it is 0 guys, then only what, you are going to have what, a 0 change in the speed. So because guys, it is tangentially acting. Okay, it is tangentially acting on the particle, that's why it is known as what guys, tangential force, or you can say tangential acceleration would be the effect of that force. Okay, so guys, of course, because the speed is not changing, we will say that the tangential acceleration in this case would be what guys, 0. I hope you are getting my point, what I am trying to say. So guys, now you may ask, then sir, what is the meaning of what, dv by dt? Okay, so let me discuss this for you. Okay guys, so if you see dv by dt I am going to derive here, guys. It is going to be very very interesting. Okay, so if you see, guys, dv by dt can be written as what, guys? D of mod v into v cap divided by dt equal to what? Equal to, sorry, guys, okay, that we have to find out, now if you see, guys, the mod v is not changing with the time, so we will take mod v as outside, guys, and what is remaining? dv cap by dt. Okay, so now, guys, if you see here again, let me go back and let me explain to you, guys. Here if you see that the v cap is basically the direction here, na? The v cap is what, guys? The direction here. So if you see, the v cap is continuously changing, the direction of v cap is what, guys? Changing. So if you see, guys, if we take this as a reference line, so, guys, here let me choose some other color so that we can differentiate this. So, guys, here the v cap direction is what? Nothing but what? Theta cap. Here, guys, v cap direction is what? Nothing but what? Theta cap. Here, guys, this is what? Nothing but what? Theta cap direction. Here also what, guys? It is nothing but what? Theta cap. So what we can do, guys, we can replace the v cap by theta cap direction. Okay, there is no problem because the magnitude of both unit vectors are what? One only, and the direction of velocity vector is equivalent to what? Theta cap direction. Okay, so I can replace what? The v cap with the theta cap. Okay, so let me replace this, guys. Okay, so what I can write, guys, now if you see, I can write this as v vector into d theta cap by dt. Is this or not? So now, guys, if you see, it is very very easy. So dv cap by dt can be written as mod v into d theta cap by dt, and, guys, d theta cap by dt we have already discussed, that is what? Minus omega r cap, so, guys, what we got from here? Is dv by dt is nothing but what? Is equal to v into omega minus r cap, minus v into omega into what, guys? R cap. Means the rate of change of velocity in the case of uniform circular motion would be, guys, come into what, guys? Minus v into omega into r cap. If you see, guys, the direction of this acceleration that is coming here is coming towards the center. Okay, if you see, r cap direction is what, guys? R cap direction is always in this direction. This is the r cap direction. Let me, yes, if you see, r cap direction will be what? Here r cap, here what? R cap. This is what, guys? R cap. Okay, so minus r cap direction will be what, guys? Like this, guys. So it means the acceleration that we are getting here mathematically is what, guys? Is nothing but what? It is coming towards the center. So, guys, this acceleration which is coming towards the center is, guys, known as centripetal acceleration, which is acting towards the center, guys. It is known as what? Centripetal acceleration. So, guys, if you see, this is acting towards the center, it means it is always perpendicular to what? Velocity. It is always perpendicular to what, guys? Velocity. Let me make the diagram so that I can show you something, guys. If you see, this is very interesting, and don't worry, guys, right now I'm talking in terms of pure math. Okay, later I will try to like visualize this thing physically also. Okay, so uh, let's see, guys. Okay, let's see. So if you see here, so, guys, here if you see that this is your velocity vector, and this acceleration is, guys, what? Acting in this direction, a centripetal, I am saying. Okay, so if you see, if a centripetal is acting in this direction, we can say the force that is acting, the force due to which the a centripetal is coming will be also what, guys? Acting in this direction. And if it is acting in this direction, it means what, guys? This force is not changing the speed of this. Okay, and of course, if it is not changing the speed, then what it is doing, guys? It is only doing one thing, guys. What? It is helping the particle to change its direction. It is helping the particle to change its what, guys? Direction, nothing else. Okay, so this force which would be acting on this body, due to which this a centripetal is coming, is only helping to what, guys? To change the direction of what? Velocity, nothing else. Okay, it is just helping what, guys? To change the direction of velocity, nothing else. it is taking no part in the increasing the speed, guys. That could be done only by what? Tangential acceleration, okay, which is not acting right now because we are discussing only the uniform circular motion. So guys, here the a centripetal, the job of this force is what? To maintain the body to move on the circular path, okay, to maintain the body to move on a what? Circular path, okay. So guys, that is what your centripetal acceleration, and of course it will come due to some force, and that force will be known as, guys, what? Centripetal force, that we will see in the future, okay. Now guys, this is, if you see, this equation looks like a little bit what? Little bit in a scalar form, okay. How do we write down this in a vector form also, guys? Let me do that also, okay, let me do that also for you. So if you see, guys, we have developed one relation, if you remember, that is what? V is equal to what? Omega cross r. Just before this we have developed this relation, guys, okay. So now guys, here if you see, I am going to analyze this for uniform circular motion. So for uniform circular motion, uniform circular motion, if you see, guys, the dv by dt that we were looking at to find out will be equal to what, guys? D omega by dt cross r plus omega cross dr by dt. Is this okay, guys? I hope you're getting my point. But guys, if you see, we know that in the uniform circular motion the angular velocity is what, guys? Constant, okay. In the uniform circular motion, guys, angular velocity is what? Constant. Its magnitude is also constant, and its direction is also what, guys? Constant. Like in the start I have discussed that the direction of velocity was what? In the upward direction, okay. If, let me show you, okay, just for you again. As if you see here, the angular velocity I have shown that what? It is acting in the upward direction always, and it is covering what? Same angle in the same amount of time, guys. It means what? The magnitude is also what? Constant. So guys, it is completely constant, we can say, okay. Means omega vector is, can be treated as what, guys? Constant, okay. So the differentiation of this will be what, guys? Directly what? Zero, we can say, okay. So in that case, guys, in that case we can say that dv by dt is nothing but what, guys? It is equal to omega cross dr by dt is, guys, nothing but what? V, we can directly say. So omega cross V is what, guys? Is equal to your the acceleration value, okay. That is what? Acceleration value, that is what? Omega cross V, omega cross V, okay. That is the case, okay. Now guys, if you see here, this omega and this V, if you see the direction, if I make the diagram, we have already made it here, guys. So if you see right now, guys, if you see, in this case the velocity is in this direction, and the omega will be what, guys? In the outward direction. So if you take omega cross V, guys, if you curl your fingers from omega to V, its direction will come what? In this direction. Here also, guys, omega cross V will come what? Towards the center. Here also, guys, omega cross V will come what? Towards the center. Here also what? Towards the center. So guys, this is the general form of what, guys? Finding the centripetal acceleration, finding the centripetal acceleration in the case of uniform circular motion, okay. Because guys, this acceleration right now is the total acceleration, okay. Guys, try to understand, this is what? This is a net, this is what? A net. And of course this vector should come because of what? A tangential plus a centripetal. But guys, because we are talking about uniform circular motion, this will be what? Zero. So guys, directly a net is responding as what? A centripetal, and that is what, guys? Is equal to what? Omega cross V. So guys, this relation is not general relation. It is only true for what? Uniform circular motion. It is only true for what, guys? Uniform circular motion. That you should keep in mind. It is not true for any general set of circular motion. It is only true for what, guys? Uniform circular motion, okay. I hope you're getting my point, okay. Now guys, this direction thing, if somebody asks you that, sir, can you more go into depth of what? That how this acceleration is coming towards the center, then guys, I think we can talk about a little bit more on that, okay. How? So guys, if you see, guys, so in the last, guys, I'm going to summarize all these things. This lecture is very very important, guys, because these are the building blocks, you can say, of the whole upcoming circular motion lectures. Okay, so please watch it carefully, write down the notes. Okay, and if you have any doubt or something, you can post on the comment. Okay, maybe I'll see, and I can do something for that. I'll do it. Okay, now, guys, I have talked about the acceleration in general, like instantaneous acceleration. But guys, there is one more type of acceleration that we can analyze, that is known as what, guys? Average acceleration. Average acceleration. Okay. So guys, average acceleration we know already, that is what? Nothing but what? A average. Okay, that is what, guys? Nothing but what? A average. How it we have defined, guys, this thing in the kinematics. It is like this way: a average is equal to what, guys? Is equal to final velocity vector minus initial velocity vector and the time taken to change of this. Okay, this is, guys, known as what? Your the average acceleration. Okay, it is known as, guys, what? Your average acceleration. Now let me do this analysis, guys, in the case of circular motion. So if you see, it's very very interesting, guys. Okay, so pay attention, and if you see, mm, okay, now, guys, let me show some velocity vectors. So suppose, guys, this is the v, and this is your v initial, basically. Okay, this is your v initial. Okay, v initial vector. And guys, suppose after some time the particle has gone here. Okay, and this is your what, guys? V again, but this is your v final vector. Okay, v final vector. And let's say the particle has traveled how much? Delta theta. Radius is what, guys? R. Okay, radius is what? R. Okay, now, guys, if you see, uh, if you associate the theta, guys, with this velocity vector, if you associate this radius with this velocity, guys, and this is 90 degree. So guys, if this radius has turned up to delta theta, it means, guys, we can say this angle will be also what? Delta theta. This is a very simple math. Okay, so I hope you're getting my point. This angle will be also what, guys? Delta theta. Okay, so with this like result, guys, let me write down the first change in velocity calculation. Okay, so guys, what is delta v? What is delta v vector? That is what, guys? Vf minus vi. Vf minus vi. Okay, so guys, Vf minus vi will be how much? If you see, Vf minus vi, so guys, I am going to do this with the triangle method simply. Okay, so guys, Vf is like this. Okay, and guys, vi, the minus vi we have to add. Okay, so minus vi, guys, let me make in a separate color. So guys, this is the minus vi. I have to add this thing. Okay, so guys, let me add this here. Okay, let me add this here like this way. Okay, so if you see, 1 minute, guys, its length would be a little bit more. Okay, yes, because both are what? Of the same length. Okay, this is also v, this is also v. So guys, this is your v final, and this is your what, guys? Minus vi. Okay, so if we add both of two, guys, what we will get? We will get the result. Okay, we will get the result of change. So guys, if I take the change, it will come, guys, what? Towards the center. If you see, guys, properly, it is looking like that. It is what, guys? It is pointing towards what? Center. It is pointing towards center, if you see, guys. Okay, so now, guys, if you see, this is your delta v. This is your what, guys? Delta v. Okay, not completely it will look like that it is towards center, but majorly, guys, it will appear that it is what? Acting towards the center. As the theta will become more and more small, it will more bend towards the what, guys? Center. Okay, it will more like focused towards the center. Okay, okay, this is your delta v vector. So guys, if I write a average, okay, a average, guys, it's very interesting analysis. Okay, so just pay attention, guys. So if you see, how do we calculate this magnitude? Okay, how do we calculate this magnitude? So guys, if you see, uh this angle would be how much, guys? This angle would be if you see guys, this was v. So guys, this will be what? Theta. So by the this property of straight lines guys, we can say that this will be also what? Theta. So guys, this is v, this is v. Now let me drop a perpendicular here. So if I drop a perpendicular here guys, let me zoom this. Okay, so this is what guys, this is like this. The magnitude of this one is v also, and this one is also what is v. What we can find out, we can find out this will be how much guys, this will be theta by 2. This will be also what? Theta by 2. Okay, so 1 minute. This is delta theta, this is also what guys? Delta theta. Okay, now this will be how much guys? This will be delta theta by 2. This will be also what? Delta theta by 2. Okay, so guys, this we can write simply. This is what guys? This is nothing but what? The sine component. Okay, sine component of what? This. Okay, so this will be what? V sine delta theta by 2, v sine delta theta by 2. So we can write guys delta v as what? We can write delta v as as 2v sine delta theta by 2. I hope you're getting my point. Okay, and guys, of course the time taken. Okay, so of course the time taken. So guys, now if you see here, uh, how we can, this is what guys, this is your general relationship. Okay, this is your general relationship. Now guys, if you see what I can do, if if this delta t is tending to 0, then in that case, in that case, in that case, a average will tend towards what guys? A instantaneous. Of course it will become what guys? A instantaneous. I hope you're getting my point. Okay, so guys, in that case what will happen, let me write down. So guys, uh limit delta t tends to 0, a average will become what guys? Your a instantaneous. Okay, and that is what guys? Of course a centripetal we know already, and that will be equal to what guys? 2v. So delta theta will also become what guys? Very very small. So because delta theta by 2 become very very small guys, so here let me write down the approximation. So guys, if delta theta by 2 is very very small, means sine d theta by 2 can be written as guys what? D theta by 2. If d theta by 2 is very very small. So guys, if we put this approximation here, what we will get, this can be written as d theta by 2 divided by delta t. Sorry guys, this also we have to write as dt, because time we are taking very small. So guys, a centripetal will come as what? It will come as 2 guys, what? Cancelled out. So what we got? V into d theta by t, which is what guys? Nothing but what? V into omega. So guys, a centripetal, if you see, it is also coming what guys? V into omega. Of course it is not in a vector form, but we know that guys, v and omega is always going to be perpendicular in the case of uniform circular motion, or in general also guys, we will see that it is going to be what? Perpendicular to with each other. Because v and omega, because they are perpendicular to each other, the v cross omega, sorry, omega cross v is going to be what? Magnitude wise v into omega, or omega into v. So guys, if you see from here also, we have derived that how much is the a centripetal. A centripetal is what guys? V into omega. So now guys, let me summarize the whole analysis that we have done till now. So summary guys, summary. Okay, summary is what guys? Summary is this, that v is equal to omega cross r. Okay, omega cross r, where r is the radius and omega is the angular velocity, and it is guys true for all sorts of circular motion in general. This is true for all sorts of circular motion, there is no doubt about it. Okay, because we have derived from a very general situation. Okay, and for a very short time guys, everything is like a uniform circular motion for a very short time. For a very short time guys, it is going to be what? A uniform circular motion, be it a uniform circular motion or a non-uniform circular motion. Okay, for a very short time, and this is derived for an instant, so it means for a very short time. Okay, so I hope you're getting my point. And the second thing is, so because because omega and r is going to be perpendicular, so we can simply write v is equal to what, r omega also. Just when we want to calculate the magnitude guys, we can directly use this thing, not to worry. Okay, and after that guys, I have derived that dv by dt is equal to nothing but what, omega cross v, and this is guys only true, this is only true, only true for uniform circular motion. Not always guys, only for uniform circular motion, only for uniform circular motion, not always. Okay, so guys, from here what we have derived, that a tangential is 0 for UCM. Okay, uniform circular motion guys, we can call it in short UCM. Okay, so a tangential is going to be 0, and guys a centripetal is going to be what, it is going to be omega into v minus r cap, if you want to write down, because it is acting towards the center guys. So that is going to be the value of this, and of course this is the vector form. Okay, if you want to, if you can remember guys, remember these two, that is going to be very very helpful in the future. Okay, and AC is equal to what guys, omega into v. Now there are some other form of what guys, a centripetal is there, that you should keep in mind, because many times it will use get like it will be used directly guys. Okay, the first thing is what, of course minus omega v r cap, and there is another way guys, if we replace omega, if we replace guys omega uh, by what, by v by r, then what we will get guys, so if we replace the omega by v by r, we will get this as guys what, minus v square by r r cap. Okay, this is the second way of writing this. And third way is what guys, if we replace guys what, v by what, r omega in this equation, then what we will get guys, we will get as minus omega square r r cap. Okay, so all these three are guys what, the like manipulations results. Okay, by these two equations. Okay, by these two equations we have derived these three different form of what, relationship for a centripetal, and these are helpful guys, as per the questions requirement we will use those. Okay, in the future. Okay, we will use those in the future. Now guys, this is about what, this is about the uniform circular motion. We have discussed very detail, we have discussed all the things. Now guys, after this we are going to discuss in the next lecture about what, I'm going to discuss guys about the accelerated circular motion. Okay, accelerated circular motion guys, I will discuss in the next lecture. Okay, of course like after 1 to 2 lectures, okay, we will be ready enough to take some illustrations or some problems in this chapter. Okay, physics is like this way only guys. Okay, first 3 4 lectures might be only the theory, just building foundation of what, the chapter, and after that when the concepts get built up, then only we can take some problems. Okay, so wait for some at least 2 more lectures. After that guys, we will take some illustrations also on this the topics that we have discussed till now. Okay,